Let's get started. So, question 6 right, of the on yesterday. So let's take a look at one of these questions. We have this theta from 0 to 360 degrees, and then theta is in a quadrant number 2. Sin theta equal to half. We want to find out what angle will be the angle for theta. Yeah, let's try this one. Okay, this is in quadrant 4. All right, so I'm gonna work out one of these questions. So I'm gonna show you another in a second. So this is theta is in the quadrant number 4. So you're gonna draw up this. So we try to figure out the theta, right? This is the theta we're looking for, which is the reference angle. We're gonna locate the reference angle first. So for sin theta equal to half, right? We know in the fourth quadrant it will be negative. All students take calculus. In the fourth quadrant, sin theta is minus, negative. So basically, we're looking at a half, right? And we know that for sine equal to half, it must be 30 degrees, right? This is the 1 unit, we only got about 3 degrees, right? Triangle. Yeah, so 30-degree angle, that would be the reference angle. However, we're not looking for the reference angle, we're looking for the actual angle. So this angle right here, right? This is the angle we're looking for. So the 360 degrees minus 30 degrees, which is going to be 330 degrees. And this is the answer we're looking for. Any question about this? So the answer is 330 degrees in the fourth quadrant, quadrant number 4. IV, that's a Greek letter for 4, right? So we're going to try another one. Let's see. Show me another. Okay, let's try this one. This is in quadrant number 2. All right, let's go over the solution. Again, this angle is in the quadrant number 2. So you're going to put it in the quadrant number 2. And we're looking for this angle actually. This is what we're looking for, but we're going to find a reference angle first. And in the quadrant number 2, sine is positive for student. Okay. Sine is positive. And so basically, based on this sine theta equal to square root 3 over 2, is the radical 3, is 1, is 30 degree, is 60 degree. Next to unit, meaning this angle will be 60 degree because radical 3 over 2 sine 60 degree equal to radical 3 over 2. So that's theta equals 60 degrees. Now from there, we just use 180 degree minus 60 degree. And equal to 120 degrees. And the answer will be 120 degrees. Any question about this? Okay, let's move on to the next question. So theta is in quadrant 2. Let's try this one, right? We get the cosecant 120 degrees. And another the cosecant 330 degrees. How do we solve this? Okay, I'm going to show you the detailed procedure step by step first. So first of all, you can draw something like this, right? First quadrant, everything positive. Second, sine positive. Third, tangent positive. Last one, cosecant positive. So in the fourth quadrant here, only cosine are positive. Everything else will be negative. So cosecant is going to be negative, right? So the answer is negative. And then also, we're going to use a reference angle, right? A reference angle here will be.
See your screen.
Oh, yes. Okay. Get a share. Okay. How about now? See my screen?
Yes.
Okay. Good. So, yeah. So basically, start from scratch, I guess. So all students take calculus, right? So in the fourth quadrant, only cosine are positive. So then cosecant must be negative. And so we determine the sine first, and then reference angle here will be 30 degrees. Okay, so this is equivalent to negative cosecant 30 degrees. When you use the reference angle, right? When we do the reference angle, we determine the sine first and use the reference angle. 330 is right here. And 30 degrees is our reference angle. And this is equivalent to negative cosecant is 1 over sine 30 degrees. So this is the easier way to do this, right? Just use a property of the reciprocal property, and we can get to the cosecant theta using the sine theta and sine 30 degrees. You know, sine 30 degrees is equal to half. Positive. And so this is minus 1 over half. 1 over half is times 2, right? So it's negative 2. So the answer for this will be negative 2. Any question about this?
Did you get the 30 degree?
How do I get that 30
Yes.
reference angle? Okay.
Yes.
Okay, so basically because this is 330 degree, right? That means this angle is 330 degree. And the total one cycle is 360, right? So remaining
Yes.
angle is going to be 360 minus 330 degree, which is 30 degree.
Got it.
Yeah. Okay, very good. Okay. So that's how we handle this. So the answer here is -2. And the tricky thing is determine the size, so that's why drawing that will help you a lot to visualize each trigonometric identities in each quadrant. Okay, so you guys try another one. Let's say cosecant 240 degrees. let's go over the solution here. So one more time, we're gonna locate a reference angle. So 240 degree, right? So this is 180, 240, somewhere here. Now this time the reference angle is gonna be 240 degree minus 180 degree, 60 degree, right? This is always gonna be the case. The reference angle theta is always gonna be the terminal side intercept with the x-axis, terminal side with x-axis. So the theta here is 60 degrees. So we determine the reference angle, and again, all students like this. So in the third quadrant, because this is in the third quadrant, only tangent are positive, right? So that means cosecant is negative. So the answer is negative, and using the reference angle, cosecant is 60 degrees. Yeah, so, and from there, we're gonna do negative cosecant is reciprocal of the sine, so it's 1 over sine 60 degrees. A sine 60 degrees, so we know that will be radical 3 over 2, right? Radical 3, 2, 1, right? This is 60 degrees. So radical 3 over 2, so it's minus 1 over radical 3 over 2. And right here, divide by this will be multiplied by the reciprocal, 1 times 2 over radical 3. Now we got to rationalize the denominator, right? Multiply by radical 3, radical 3. But the answer is minus 2 radical 3 over 3. Any question about this? Minus 2 radical 3 over 3. Yeah, that should be it. Answer is good, right? Good answer. All right, let's look at next problem. Yes, so it's another, I leave it to you guys, right? Another question in third quadrant. Cosine theta equal to minus radical 3 over 2. Find angle theta. All right, guys, let's go over the solution. So it's in the third quadrant. So let's put in the third quadrant first. And we're gonna locate this reference angle first. Okay. So get cosine theta equals to minus. Then the third quadrant, cosine negative. Student calculation. So only tangent and cotangent are positive and cosine is negative. So that's good. And then for cosine to be radical 3/2. So this has to be 30°, right? Radical 3. This is 3 units. So cosine 30° equal to radical 3/2. So that means reference angle must be 30°. I'm gonna use 180 adding 30, right, to get this is 180. This is the angle. Reference angle is 30, and then the angle itself would be 180 plus 30. So theta here should be 80, 30, which is 220 degrees. Does that make sense? Okay, very good. Yeah, 220 degrees. And then that's a third quadrant, right? That's located in third quadrant, which is good. Yeah, the answer is good. Okay. And this is fairly straightforward, right? You just square the sine 45 degrees. Sine 45 degrees is, yeah, sine 45 degrees is radical 2/2. And this one, sine 30°, you half square that a quarter, right? So that's, this is straightforward. So, and then let's look at next one. Yeah, so how about this? Sine 30 plus cosine 30 squared. Let's get something else. Okay, sine 60 plus cosine 60 squared. Okay, you guys try this. Alright, so you should basically get sine 60 degree, which is radical 3 over 2. Cosine 60 is half. Square that. So this is a perfect square, so we get radical 3 over 2 squared plus 2 times half times radical 3 over 2, having half square. So this is 3 over 4. This get cancelled. Radical 3 over 2, adding a quarter, right? 3/4 plus a quarter, that's 1. 1 plus, so 3 over 2. That's the answer. So basically just simplify once you locate all those values. So it's 1 plus square root of 3, 2. That's the answer. Yep, it's good. Right. And that's everything on this section. Okay, so you guys can finish this up today after class. And then we're gonna quickly talk about some of the trigonometric identities, right? Which is in chapter 11, next topic. So we're gonna focus on some of the popular ones we're gonna use. Let's see, let me quickly demonstrate this on OneNote. Okay, so trigonometric identities. Take a look at those. Let me share the screen. We'll start with the reciprocal identities, right? Reciprocal. To touch base on this, some trigonometry. Reciprocal identities. So sine theta equal to 1 over cosecant theta. Vice versa. Meaning if you have cosecant theta, it's also equal to 1 over sine theta. This is basically go because they are reciprocal of each other. And then cosine theta equal to 1 over secant theta. So if you know one of them, you know the other one. That's what how this reciprocal identity works. And if you know secant theta, if you know cosine theta, you know the secant theta. And then tangent theta equals 1 over cotangent theta. And cotangent theta equal to 1 over. Yep. So this is a typical reciprocal identity. If you know any of the 3 identities, then you know the other 2, right? And also we have the next one is called a quotient identity. There are just a couple of the like quotient identity based on the sine, cosine. So tangent theta equal to sine theta over cosine theta. And cotangent theta, and it's a cosine theta over sine theta. So these are very, very common characteristics we can use to tackle a lot of different problems based on these basic identities. There's also Pythagorean identities. Pythagorean identities. I'm going to show you how to prove this. Actually, most of these identities, all of them actually has a proof. I'll show you how to prove some of these identities. Give you some perspective on this. So first one is the sine theta squared, sine theta squared plus cosine theta squared equal to what? Now you draw the right triangle, right? And you'll be able to prove it fairly quickly let's say this is angle theta. Now, assuming this is A, this is B, that's C, right? Now from here, sine theta is going to be, we should put in the general term, right? As long as it's the right triangle, this works. A over C. And then cosine theta here is B over C. Now if you throw in both of them, and we know that because it's the right triangle, so A squared plus B squared equal to C squared. Right, it's Pythagorean theorem, right? That's why it's called Pythagorean identities. All right, so going back here, so this one will become A over C squared. This one is B over C squared. And we're gonna prove it's equal to 1, right? And let's see how that goes. So A squared over C squared plus B squared over C squared. Is that equal to 1? We don't know yet, but we're gonna figure out that. So A squared plus B squared, put question mark here, over C squared. And then we know A squared plus B squared equals C squared. So this is the same thing as C squared over C squared. That is 1. Right? So basically we prove the first Pythagorean identities. Right? Any question about this? And the second identity comes from this first one, right? Which is 1 plus tangent theta squared equal to secant theta squared. Right, so secant theta, this is another Pythagorean identities. I'm also going to show you how to prove this. It comes from the first identity here. If you have a okay, sine theta squared, we just prove this, right? So now we can use it. Cosine theta squared equal to 1. If you divide everything by every single term by cosine theta squared, right? This by cosine theta squared, by cosine theta squared. That basically we get this identity right here. So sine theta, so you're gonna split it as sine theta over cosine theta squared, put a square term outside, right? And then cosine theta squared plus cosine theta, that's what. Same thing, this becomes 1 over cosine theta, move it outside, right? Put the square term outside, and we get the identity. Yep, so sine theta over cosine theta tangent theta square, we get tangent theta square plus 1 equal to 1 over cosine theta, it's a secant theta, right? That's secant theta squared. So basically, we prove it. Okay. Now, similarly, I want to prove this one. Third one is the third Pythagorean identity is 1 plus cotangent theta squared equal to cosecant theta squared. I want you to take a couple minutes. It's going to have similar proof like this, right? Similar to this. See if you can figure out how to prove this one. All right, anybody want to share your idea how to prove this? Nope, no idea. Okay, no problem. You just basically get the original identity, right? Just move that one. So cosine theta squared plus sine theta squared. Yeah, it's the sine theta squared. Equal to 1. Now you're just going to divide everything by sine theta squared. Sine theta squared. Now, move the power outside. We're going to get cosine theta or sine theta. And square that, right? And cosine theta over sine theta, that's a cotangent theta. This one, sine theta squared over sine theta squared as well. Same thing here, 1 over sine theta. We'll move the square outside. Now, cosine theta over sine theta is cotangent theta. Square that. Plus 1 equal to 1 over sine cosecant theta squared. And so that will just prove it. So this is also very important properties, and then sometimes we use it to simplify the trigonometric expressions. And also we have an even odd identities, right? Even odd. So sine negative theta. Basically, sine is our function, so it's equal to minus sine theta. And then cosine is even function. Cosine negative theta equal to cosine theta. And then tangent is our function. Tangent negative theta equal to negative tangent theta. So tangent is odd, and then cotangent is odd. Negative cotangent theta. And secant would behave the same way as the cosine. So secant is an even function, secant theta. The last one is cosecant. Cosecant will behave in the same way as a sine theta. So cosecant negative theta equal minus cosecant theta. So, and if you want to look at this really quickly, actually, it's not hard to prove this, right? Let's say this is the angle theta, right? And this will be negative theta, right? And then we know that sine theta will be positive, right? This is positive. And then now sine negative theta, all students in calculus, right? Sine negative theta will be negative. So that's why it's equal to minus negative sine theta. So basically, we just prove it. This is a value. And then for cosine, right? Cosine negative theta, because cosine in the fourth quadrant is positive as well. So cosine negative theta is the same thing as a cosine theta. And then if you prove, once we determine, sine is odd, this is an odd function, cosine even, and we get a tangent which is odd over even, right? Odd over even is an odd function. Okay, so that's why tangent. You can also do something like this, right? Theta here, tangent negative theta. Tangent in the fourth quadrant is negative, right? That's why it has to be minus tangent theta. Because all of these are positive. Positive, positive, positive. All of these positive, right? Because we are assuming theta is in the first quadrant. Theta is greater than 0, less than 90 degrees. And so we can prove all of this just based on this simple graph right here. This is even really this. I think I mentioned something last class. The last is called cofunction abilities. We did something like sine 30 equal to cosine 60, right? That's exactly the cofunction. For example, like cosine of 2 minus theta. Basically, they are the complementary angles. These two angles, this theta and then 2 minus theta, they are complementary angles. And we have cosine on one side, sine on the other side, they are equal to each other. Similarly, sine over 2 minus theta equal to cosine theta. A quick proof will be cosine 60 degrees, right, equal to sine 30 degrees. We observed that yesterday from this graph right here. This is 30 and this is 60, radical 3, 1, 2, right? So cosine 60 is half. Sine 30 is also half. They are equal to each other because these two are the complementary angles. When you sum up those, they are equal to 90 degrees. This angle plus this angle, 90 degrees. And tangent of the 2 minus theta equals cotangent theta. Again, they are cofunctions. Now cotangent of 2 minus theta equals to tangent theta. And secant of 2 minus theta equal to cosecant theta. And cosecant of 2 minus theta equal to secant theta. So this is called cofunction identities. There are many more identities, right? But again, this is an intermediate algebra, so I don't want to go too deep into this. You're gonna learn some more in the pre-calculus class, maybe also in the calculus class. You know, if you move forward, so you're gonna learn some more from there. So this is good enough for now. So let's go to the exercise from the web work. Let's do some practice using some of the properties here we talk about. So let's look at trig identities, right? 1101, that's a trig identities. Let's start looking at the question number 1. Okay. And if suppose cosine theta equal to this, then compute the trigonometric values below. Okay, now remember, yeah, I'm looking at a new one. Here we go. So let's look at this one. We know cosine want to get to secant. How do we do that? Any suggestion? Secant theta equal to 1 over cosine theta, right? So they are reciprocal of each other. So you know cosine, you know secant. So secant theta will be reciprocal of this. So that means 29 goes on top and 2 radical 29 goes on bottom. Now here we can just multiply radical 29 from top and bottom. We get minus 29 radical 29 over 2 times 29. Now cancel 29. We get minus radical 29 over 2. Any question? Reciprocal identity. Okay. So if this will be minus radical 29 over 2. Check answers. It should be good. Yeah. All right, so Yeah, let's look at next problem. Now you get cosecant theta. Let's find the sine theta. Let's try this. Okay, you guys try this. Okay, so basically sine theta equal to reciprocal of equal to 1 over cosecant theta. So it will be 3 over radical 34. Now you rationalize the denominator, radical 34, radical 34. So 3 radical 34 over 34. So that should be the answer. 3 radical 34 over 34. And that's good. Let's look at the next question. So let's say first quadrant is not interesting. Let's see. What if it's second quadrant, right? You are given the cosine theta, and you want to find out the sine theta, assuming theta is located in the quadrant number 2. Use some of the trig identities to solve it. I'll give you some time to try this. All right, let's go over the solution. So you're gonna use the Pythagorean identities for sine theta square plus cosine theta square. It's equal to 1. And also second quadrant, right? So we also need to determine the sign. In the second quadrant, sign is positive. So second quadrant sign positive. And use is positive, right? So and we get rid of the square root. We want to keep the positive answer here. So sine theta squared cosine theta, we're going to replace it with the -4/5 for the 1. Sine theta squared plus 16/25 equal to 1. 1 is 25/25, so it's 9/25. So sine theta squared equal to 1 minus 16/25. 25 minus 16/25, that gives us 9/25. So sine theta squared is that, and we take the square root, only keep the positive answer. So it's a square root of 9, 3/5. So the answer is 3/5. Supposedly there are two answers, but because of this constraint, quadrant number 2, then only one answer satisfies all conditions. So the answer is 3/5. Any question about this? Now, yeah, given the sine data, we're also looking for cosine data. Let's try this one. That number is too familiar. Yeah, let's try this one. This is better. All right, let's go over the solution. It's in the theta is located in fourth quadrant, so cosine is positive, cosine positive. So the answer will be positive here. So again, one more time, we're using the background identities and theta squared plus cosine theta squared equal to 1. And here sine theta is minus 12 over 13. So that adding cosine theta squared. We're looking for and 12 squared, that's 144. 13 squared, 169. Plus cosine theta is 1. Now subtract 144 over 169 from both side equation. Cosine theta squared equal to, this is 169 over 169. And same denominator, subtract the numerator, you get 25 over 169. Now we're taking the square root from both sides of the equation, but I only keep the positive answers here. Cosine theta is going to be equal to square root 25, 5, square root of 169 and 13. The answer is 5 over 13. Positive. Any question about this? Let's try. Yeah, this is unusual. This is not a normal numbers, right? Let's see. No special numbers. Let's try this one. Theta is located in the third quadrant. Okay, let's go over the solution. So first of all, it's located in the third quadrant. So both sides and cosine negative. Sine negative. Cosine theta negative. Okay, so the answer must be negative. And again, we're using the Pythagorean identities. Sine theta squared plus cosine theta squared equal to 1. And we're solving for sine theta. Cosine theta square will be minus 1 over square root of 26 square. 1. So sine theta square is 1 over 26, no, plus 1 over 26 equal to 1. And you subtract 1 over 26 from both sides of the equation. So we get sine theta square equal to 25 over 26. 26 minus 1 is 25 over 26. And sine theta is negative. So we're just going to keep the negative answer here. For sine theta square minus square root of 25 over 26. Now from here, we get sine theta equal to minus square root of 25 is 5 over square root of 26. We rationalize the denominator by multiplying radical 26. And when we simplify, we divide with minus 5 radical 26 over 26. Okay, so that's going to be the answer. So it's minus 5 radical 26 over 26. Yep, so that's the answer. All right, so now here we get sine cosine, right? So we're going to use the quotient property to get the tangent. Given sine cosine, get tangent, right? Try that really quickly. All right, let's go over the solution. So sine theta equal to tangent theta equals sine theta over cosine theta. So we get 5 radical 34 over 34 over 3 radical 34 over 34. And we change the middle division sign to multiplication. This is complex fraction. And you get 5 radical 34 over 34 times the reciprocal of the bottom. 34 goes on top, 3 radical 34. And basically just cancel the common terms, and that was 5 over 3. You can also directly cancel this thing, right? If you don't want to go through this complex fraction, This is the same as that. If you cancel that, you get 5/3 immediately. Right, so answer is 5/3. So let's see, next question. So we are given this cosine theta, you want to find out the rest of the stuff, right? Using these auto identities. Okay. Quadrant one, no, that's not the tries and the quadrant, but the quadrant three. Okay. You guys try this, right? See if you can figure out how to solve this. You know cosine, you know sine, right? You know cosine, sine, you know tangent, and you know the rest of them. Okay. Let's go to the solution. To start with the quadrant 3, so we need to determine sine of sine theta, and quadrant 3 sine is negative. So we start with the Pythagorean theorem, right? So sine theta squared plus cosine theta squared equal to 1. Let's figure out the value for the sine theta. So sine theta squared plus minus 12 over 13 squared equal to 1. And sine theta squared plus 144 over 169 is equal to 1. Let's subtract 144 over 169 on both sides of the equation. This is 169 over 169. When you subtract it, you get 25 over 169. So sine theta squared equal 25 over 169. From here, we take in the square root. Get sine theta minus radical of 25 over 169. Then when we simplify, we get sine theta equal to negative 5 over 13. Now, once you know sine theta, the value of the sine theta, then we know in the third quadrant, cosine, that tangent is positive, and cotangent is positive. This is negative, negative. And so tangent equal to sine over cosine. Tangent theta, using the quotient property, sine theta over cosine theta, we end up with a positive 5 over 12. Okay. And then when we flip it, we get 5 over 13. Negative factor canceled. So 5 over 13 times 13 over 12. And here we cancel 13, so we end up with 5 over 12. So this is 5 over 12. And no tangent, no cotangent. Cotangent is reciprocal of tangent of 5. And secant is reciprocal of cosine, it's minus 13 over 12. And then cosecant is a reciprocal of sine, so minus 13 over 5. Any question about this? So let's put in the answers, minus 5 over 13. Tangent is 5 over 13, 5 over 12. Secant is 1 over cosine, reciprocal of cosine, minus 13 over 12. Cosecant is reciprocal of sine, so minus 13 over 5. And cotangent is reciprocal of tangent, so 12 over 5. So let's do it. It's all good. Now let's look at question 8. Right, so you want to express this in terms of the secant. We have secant and cotangent. And you want to express in terms of sine and cosine. You guys try this very quickly. All right, so let's quickly go over this. Secant equal to 1 over cosine. Cotangent is cosine x over sine x. Here we cancel cosine x, so it's 1 over sine x. 1 of sine x is equal to cosecant x, but we just want to answer as a sine and cosine. That means that's what we want, right? So it will be 1 over sine x. Let's show it. All right, so let's look at question 9. Let me see any new version. Yeah, no new version. Simply simplify this. Cosine x over secant x. Let's quickly go over solution here. So secant becomes 1 over cosine x. And then just use the complex fraction, replace it with the reciprocals, then get a result. So you get cosine x over 1 over cosine x. That will be cosine x times cosine x over 1. That's cosine x squared. So the answer is cosine x squared. The open parentheses cosine x, close parentheses square f. Yep. This last question. Let's see. We versions here. Right? We gotta try this, and then we're gonna wrap up this section. Okay, guys, we're gonna take a 30 minutes break, come back at 10:45. All right, guys, let's resume. Let's finish that problem. Give a couple minutes, finish this. I'm gonna move on. All right, so we make a fraction here, and on LCD, with LCD, are the sum in terms of sine and cosine. So LCD sine x. So multiply sine x for the first term, then cosine x, sine x, over sine x, plus 1 over sine x. Keep the sine x, so you get a cosine x and sine x. They want everything in terms of sine, cosine. You could simplify further, but I think that's the best we can do. In this case, cosine x times sine x and 1 over sine x. That should do it. Yeah, it is correct answer. So now, the last topic is on chapter 12 on the right triangle trigonometry. Let's take a look at some of the questions here, which is solving the right triangle, 1201. And this is the last topic we're going to cover, right, for this immersion program. All right, so let's take a look at some of the questions here. Yeah, so consider triangle ABC, right? That's a right triangle here. Angle C is 90 degrees. Let me see. There's some other numbers. Yeah, 15, 17, let's go. Okay. Consider this triangle ABC with the angle C equal 90 degree. Okay, so this is the right triangle. Then we get A equal to 15, C equals 17. Then you want to find out sine, cosine, and tangent, cotangent, secant, cosecant. Let's look at it. So now we can draw a right triangle. Angle C, that's 90 degrees. Yeah. And then A is 15, let's say this is the A. B, C, A is opposite side of the A, that's 15 units. And then C is 17 units. This is C. C is 17. Now, first of all, we're going to use Pythagorean theorem to find out the vertical speed. Figure out B, and then once you have the A, B, and C, then we can find out the rest of the trig identities here. So we do A squared plus B squared equals C squared. And let's solve for B. So 15 squared plus B squared equals 17 squared. 15 squared is 225 plus B squared equal to 289. Now subtract 225 from both sides of the equation. And so that B squared equal to 64. And we are dealing with a real world triangle, right? So the answer is always going to be positive. So it's positive. square root of 64, so B equal to A unit. So here B is A unit. Now, this is angle A. So sine A will be the opposite 15 over 17. And cosine A is going to be B is 8, A over 17. Tangent A is going to be A over B, so 15 over 8. Secant A is reciprocal of the cosine, right? So which is 17 over 8. Or you can do hypotenuse over adjacent. Secant is equal to hypotenuse over adjacent. This is the original definition of the secant. And cosecant is going to be reciprocal of sine, so 17 over 15. And then cotangent will be reciprocal of the tangent, so A over 15. Any question about this? Okay, 15 over 17. Cosine A over 17. Tangent is going to be 15 over 8. Secant is reciprocal of the cosine, 17 over 8. Cosecant is reciprocal of sine, 17 over 15. And then cotangent is reciprocal of the tangent, A over 15. Okay, so now we do it. Check it. Should be all good, right? So you guys try one of this. Let me get another problem. 1, 2, 5. So very good. Yeah, you guys try this.
Mister, you already take the attendance?
Not yet. I'm gonna do that right now today.
Okay, okay, thank you. I'm gonna open the attendance sheet right now, and then I'm gonna call attendance in a second.
Okay, I'm calling attendance heightened.
I'm here.
Barbara. Barbara, are you here? Yeah, I see your name. Okay. Amaya. The Miljo. Daniel. Deprimonia.
Here.
Good. Cedar is here. Ivan.
Here.
Okay, great. Pam.
Yes, I'm here.
Okay, very good. And Tom.
Yes, I'm
Daniel is
here.
here.
Okay, good. Victoria. Victoria. Li Shen.
I'm here.
Sorry, sir. Daniel's here.
Huh? One more time, what's your first name?
Daniel's here, sir.
Oh, yeah, I got you, Daniel. Yes, I saw it. I also checked the list on the.
Did you call my name, sir?
meeting, so yeah,
Okay, thank you, sir.
sure, yeah, no problem. And
Did
also
you call me yet?
Guang Yu. Guang Yu, are you here? All right, so again, everybody on the attendance sheet.
Mister, you call my name?
Yes, I got you, see that.
Okay.
Did you get me?
thank
Sir,
you. Thank you.
I
Did you
go
get me?
to the restroom just
Um,
now. Do you call me?
What's your first name? Guang Yu,
Drew.
that's you. Yes, I call your name. Yes, I marked you in the.
Oh, okay.
Did you call me?
I just go to the restroom. Sorry.
Yeah, no problem, no worries. Yeah. The Miljo, I also got you. Yes, I marked you.
Okay.
Yeah, so don't worry. I usually, if I don't see your name on the Zoom, I will usually call again. And I see your name, I just skip it, I just call once. Yeah. But if I cannot find you on the Zoom meeting, I usually will, you know. I'll look harder. Let's go over the solution here. That's one more time to the right angle. And then label this. This is angle C, 90-degree angle. This is A, that's B. A is here. A is equal to 12 units. And C is 13 units. A will be 5 units, right? 5, 12, 13. Yeah, no, B is 5 units. So you can also use Pythagorean theorem, right? Let's do that. B equal to 5 units. So the sine A, this is angle A. Sine A is opposite over hypotenuse. So it'll be 12 over 13. Cosine A will be adjacent over hypotenuse, 5 over 13. Tangent A is opposite over adjacent, right? So 12 over 5. And secant A is hypotenuse over adjacent. Yes, so it'll be 13 over 5. And cosecant A will be hypotenuse over opposite. So it's 13 over 12. And cotangent would be adjacent over opposite, right? So it'd be 5 over 12. So that's how you get product numbers. Any question? So is 12 over 13. Sine A, cosine A, 5 over 13. Tangent is sine over cosine, right? 12 over 5. You can use reciprocal of the cosine 13 over 5. Cosecant reciprocal of sine 13 over 12. Cotangent is reciprocal of tangent, so 5 over 12. That should do it. Yeah, it's all good. Let's look at next problem. So this is similar one. So we're gonna skip this. You guys can try this. So now let's look at this one right here. So you want to find out sine A, cosine A, sine B, cosine B. Given 9, A is 9 units, B is 3 units. I'll let you guys try this. All right, let's go over this. So A is 9 units. B is 3 units. And then let's find out C using Pythagorean theorem. This is 90-degree angle. So C squared equals to A squared, B squared. C squared equals 9 squared plus 3 squared. So C squared is 81 and 9, that's 90. C squared is 90. And now we're going to take the square root, right? Then keep the positive answer. Square root of C squared C, square root of 90. And then 90 is 9 times 10. So that becomes C is equal to 3 square root. Okay, so C 3 square root 10. Now this is angle A, this is angle B. So A here. Sine A would be the opposite 9 over the hypotenuse 3 radical 10. So it's not over 3 radical 10. We reduce it, right? 3 going to 9 3 times 3 over radical 10. Multiply radical 10 from top and bottom. This is 3 radical 10 over 10. And cosine A, Jason 3 over 3 radical 10. And so that's 1 over radical 10. Multiply both top and bottom by radical 10. The result is radical 10 over 10. That cosine A. And then sine B, it's going to be the same as cosine A, right? Without calculation, if you just sine B equal cosine A, right? Because these two are the complementary angle. Angle B plus angle A equal to 90 degrees. So using the cofunction properties, right? Cofunction identities, cosine A should be equal to sine B. And we can double check 3 over 3 radical 10, right? It's the same. So it becomes radical 10 over 10. And then cosine B equal to sine A, right? Again, they are complementary angles. So we have cofunction identities apply here. So it's going to be, if you do directly cosine B, is 9 over 3 radical 10. And that gives us 3 radical 10. So that's all the answers. 3 radical 10 over 10. This is radical 10 over 10. Radical 10 over 10. And 3 radical 10. Any question about this? Okay, so check the answer. We should be good. Right, so let's move on to question 24. Yeah, so this one is slightly new. Okay, so this one we're going to use calculator, right? I'm going to try one of this. Haven't done anything like this yet. So okay, so we get an angle C here is 90 degree, and angle A here is 10 degree. C is 11 units, and then you want to find out the A. Okay, so you're going to use trigonometric identities to locate the A. Then we'll need a scientific calculator to tackle this problem in a second. All right, so first one, let's set up using the proper trigonometric identity, right? So here angle A is 10 degree. This is 90 degrees, so we have the right triangle. So here there's a relationship between C is given, right? C is 11 units. A is what we're looking for. And then when we do the ratio of A over C, that's a sine of A. So we're going to do sine A, sine of angle A equal to A over C. Then we're making connection between the unknown A and then two angle and also the the given quantity of C, 11, right? So sine A will be sine 10 degree equal to A over C. Okay. And from here, let me see what the calculator will need. Right? So C is 11 units. Let's put in 11 units here. And A is equal to sine 11 times sine 10 degree. We may need to convert it to the radian measurement. Let's take a look at what the calculator will look like. So we're gonna do sine, right? Sine 10 degree. There's no degree icon here. Do we have degree icon? Yeah, we don't have degree icon, so that, oh yeah, there's a radian and degree, right? So in this we have degrees, so we can put in sine 10 here. Just put in the number 10. We recognize that degree measurement and then times 11. Okay, that should be 1.910, right? So the answer is 1.910. And now let's use a radian measurement. So 10 degree. I'll just quickly check with the radian measurement. Just want to keep both options open. Pi over 180 to x over 10. Right? So in that case, we're going to get the 180x with 10 pi. And we divide both sides of the equation by 180. Cancel that x equal to reduce it, you get the pi over 18. So the radian measurement will be sine pi over 18 equal to a over 11. So a equal to 11 times sine pi over 18. Now let's just want to confirm that both give us the same answer from the scientific calculator. So here we're going to do sine and come back to the 11 times radian measurement sine of pi over 18. And then you see it's the same result, right? Right, so yeah, so the same result, 1.910. Meaning if you put in the radian degree measurement, you usually get the same result. 910. That's the correct answer right there. Check the answer. It's good. Okay. Let's see. You try one of the questions here. 10 degree. Let's try something else. Yeah, 80 degree. Let's try 80 degree. So A is equal to 80 degree this time.
Let's go over solution. So this angle A is 80 degrees. And C is 60 units. Now again, we're gonna use the sine of angle A equal to A over C. I'm replacing angle A with 80 degrees. And now replace C with a 16. So the sine 80 degrees equal to A over 16. Now multiply both sides of the equation by 16. Cancel that. Cancel 16 equal to 16 times sine 80 degrees. And we can use the scientific calculator. Right? If you're converting 80 degrees to radian measurements, I will go from the 80 to actual 80. 180 times x equals 80 pi. 180 from both sides of the equation. We reduce it by we get 4 pi over 9. So this is the same thing as 16 times sine 4 pi over 9. Some of your calculator may not have the degree measurement. You have to change the setting for the degree measurement. So it's usually easier to put in the radian measurement. It will work everywhere. Right? So 16 times sine 4 pi over 9. Let's put in your calculator. 16 times sine 4 pi by 9. So that gives us 15.757. 15.757. Is equal to approximately equal to 15.757. Let's put it in to how many to nearest 10. So they only want one decimal, but it's okay. We can put in more decimal. It's more accurate. They will take it, right? If you put in 15.8, that should be good as well. One decimal should also be correct answer. Okay, so now any question about this? Now here we are given you want to compute the angle B using calculator run to the nearest 10th of degrees. Okay, so we are given A and B, right? And then we make connection, figure out angle B. Let's try it together first. So C at A is 14, B is 6. We don't need C, right? It's not necessary. We don't need that. We can use either sine, cosine, tangent, right? Or you can also get C if you want to, but it's not necessary. So we're gonna do A over B, right? Or B over A using tangent or cotangent of angle B. So we are looking for angle B here. Angle B. So if you do tangent B, tangent of angle B, we get opposite over adjacent. So it's going to be B over A. So it's 6 over 14. If you reduce it, it's 3 over 7. Then we're going to do the inverse, right? We call this arctangent. So this arctangent, so angle B equal to arctangent of 3 over 7. So angle B is the inverse, right? Angle B equal to arctangent of 3 over 7. Then I will just put into the calculator and get the result. Let's go back to this, and then we're going to do degree measurement. I'm going to do arctangent function. You see this tangent, right? Tangent -1 means arctangent. So tangent -1, and now we're going to do 307. And that will give us a degree measurement. It turned out to be 23.2, right? 23.2 degrees. So this is also arctangent. Arctangent, it's the same thing as tangent -1, right? Inverse of the tangent. So this is angle B is approximately 23.2 units, 23.2 degrees. Any question about this? 23.2, that's right. Yeah, it's correct answer. But you can use any, right? If you do use cotangent, that's okay, but most of the calculator, as you can see, there's only arcsine, arccosine, arctangent. Right? So you gotta work with your calculator. Whatever your calculator renders. Sometimes you may need to use arcsine or inverse of sine or inverse of cosine based on the given conditions in your question. Now let's go back to this, and let's try another one, right? You gotta try another one. And given A and B, now you want to find out compute angle B. Yes, so let's go over the solution. Again, we're looking for angle B. And then you can do tangent, you can do cotangent, but the tangent is more convenient. Since I use that, that's the most scientific calculator. So the tangent B equal to B over A. B is 14 units, A is 4 units. So it's 14 over 8. And now, in order to get the simple part first, tangent of angle B equals 7 over 4. About here, we do the inverse, right? Angle B equal to arctangent of 7 over 4. So we can tangent the 1, 7 over 4. Okay. So then let's go back to the after the get the result. Seven by 4. Then we get the degree measurement right away, right? So 60.3 degrees. 60.3. That's the answer. So the angle B here is 60.3 degrees. All right, so going back to the bubble, 60.3 degrees. I check it. It's the correct answer. Any questions? Next problem. Now you want to find out angle B. You want to find A and a B, right? So we get another question. 47. Okay. So theoretically, it could be any, right? So you are given a couple angles, and then you want to find out the missing angle, and then a couple other values. And again, this is special angle, so no calculator needed. You can get the result without using a calculator. And we know angle C is 90 degrees, and the angle is 30 degrees. That means angle B must be 60 degrees. Right? When you sum up those three, so 30, 60, 90 degrees, this is a special angle. So angle B is 60 degrees. Then we also need to find out this A and B. C is 47. For the opposite side of the 30-degree angle A is half of 47. So A is 47 over 2. And then the B will you do this, right? So we're going to use the cosine 30. Cosine 30 degree equal to B over C. Cosine 30 is radical 3 over 2. And we're looking for B. C is 47 units. Cross multiplying with circle. So 2B equal to 47 times radical 3. Now divide both sides and put them by 2. B equal to 47 radical 3 over 2. 47 radical 3 over 2. So still, right? This is 1 radical 3, 2. Right? 1 radical 3, 2. Any question about this? Angle B is 60 degrees. A is 47 by 2. B is 47 radical 3 by 2. We get all three of them. Check the answer. They all good. So this one is, yeah, this one is different. Okay. You guys are gonna try this, right? Let's see. I get a special angle one. Okay. This is not a special angle, so you need to use a trig identity to get it. Let's give it a shot. And let's go over the solution. 90 degrees. So the other two will be 90 degrees. A is 80 degrees, and angle B will be 10 degrees. So figure out the angle B. And then we want to find A, then we need to use the figure entities, right? So you're going to do sine of angle A. You can also use angle B, but it doesn't matter. Either you're using angle A or angle B. Sine A is equal to A over C. Sine A is 80 degrees, so sine 80 degrees equal to A, that's what we're looking for, C is 21 units. And then make the proportion cross multiply A equal to 21 times sine of 80 degrees. A, let's see what that is. We're going to use a calculator to get the result. So go back here, 21 times sine. I'm going to use degree measurement. Go back to the main, get 80 degrees. And the answer is 20.7. Let me see how many decimal they want. Nearest 10, so one decimal is good enough. So 20.7 units per A. And then for B, we're going to use, if you stick with the angle A, that will be cosine A. Cosine A is B over C. And here we're looking for B, so cosine of 80 degrees equal to B over 21 units. Portion cross multiplying B for 21 times cosine of 80 degrees. And one more time, we're going to use a calculator to get this. So 21 times cosine 80 degrees. 1 times cosine 80 degrees. And that gives us 3.6, right? Just when you run it to one decimal place, 3.6. So A is 20.7, B is 3.6. Okay, then let's just back to my solution to the workbook. This is 20 degree angle. And A is 20.7, B is 3.6. Okay, any question about this? Yeah, it's all correct answers.
Excuse me, I have to leave the meeting at 12 because I have a meeting with my advisor.
Yes, let me see. There's this. Immersion, right? Yeah, no problem. We can leave at 12. It's okay.
Okay, thank you.
So let's go back to last question here in this section. So roll up a hill, make an angle of 11 degrees with a horizontal. If the roll from the bottom of the hill to the top is, the hill is 2.6 miles long. How high is the top of the hill? Okay. So this is a typical question you're going to see from the real world, right? Sometimes, you know, you need to do a lamppost, right? Something like that on top of the hill. And then you can use this kind of trigonometric identity to identify how tall the lamppost is supposed to be, right? So let's take a look at this question here. So basically, right, this is the row, right? Let's say this is a row, and then up to the hill, right? Up to the hill. So to the horizontal. So this is row, and then here this is 11 degree angle here with the horizontal. If the row from the bottom of the hill to the top bottom is the bottom of the hill, all the way to the top is 2.6 miles long. Let's say this is top. How high is the top of the hill, right? So you want to figure out how high is this of the hill. So usually the hill, right, will be perpendicular to the ground, right? To the horizontal ground. This is horizontal ground. So the most important for this type of question is to visualize this. As soon as you can draw the graph, try to describe translate all these words into the graph. Then you are halfway through, right? You almost complete half of the questions. And this is 2.6 miles. And right here, we are looking for the height of the hill, right? This is the hill. Hill right here. And basically, we're looking for this A, right? A is unknown. So basically, we just set up using trigonometric identity, right? Sine of 11-degree angle equals to A over C, right? C is 2.6 units. Up the hill, the road is up to the hill. And then from here to solve for A. So A times negative A. We get 2.6 times sine of 11-degree. And then we can use a calculator to get a result. So let's go back to calculator. So we get 2.6 times sine of 11-degree. And that turned out to be about 0.5 miles. If you run it to one decimal place, nearest campus, so be one decimal place. So A is about 0.5 miles. Means the elevation of the hill will be 0.5 miles. Any question about this? So the answer is 0.5 miles. I think that's correct answer. If we don't have, we should have show me another. Let me double check really quickly. Yeah, I forget to. You guys can try a question right now. I'm just create a new question here. Show me another. Okay, so try this one. All right, let's go over the solution. One more time to draw a similar graph. A row up to heel. This is a row up to the heel. This is a heel right here. There's a horizontal horizontal line, horizontal ground down below. So this is the heel. And you're gonna find out the height of the heel, right? Let's assuming this is A. I'm looking for A. And this is a 15-degree angle. Elevation between the horizontal and also the road up to the heel. And if the road from the bottom, this is the bottom to the top, it's 1.9 miles. This is 1.9 miles. Maybe you're looking for this A, right? So you're gonna do it. Usually the heel is perpendicular to the ground, to the horizontal ground. So this is a 90-degree angle here. And we can set up sine 15 degree equal to A over C. C is 1.9 unit, 1.9 miles. So if we cross multiplying, we need the proportion of cross multiplying the A equal to 1.9 times sine 15 degree. And we're gonna get a result from the calculator, 1.9 times sine 15. So that's gonna be 0.5 miles as well. Approximately 0.5 miles. If we run into one decimal place, answer 0.5 miles. Yep, it's correct answer, right? Now we finish all the topics, right, including all this exercise. So for today's homework, we're gonna finish everything all the way up to 12.1, right? So 11.1, 12.1 for today's homework. And also the rest of the 10.3, right? 10.03, evaluating trig functions, trig identities, and also solving a right triangle. Now let's log on to the website, right? We're gonna take a look at some of the questions from the website. Sign, yes, some yep, percentage, return to dashboard. So you're gonna go to our Brightspace. Maybe let me do this one more time. Then I go to Brightspace. Right here. Okay. So let me log on to Brightspace. Oh, one second. Did I open it somewhere? Yeah, sure. Okay, so let's log on to. Let's open it. Yeah, I'll go back to this. You guys can do the same thing, right? Right now, log on to Brightspace. And let's click on that link from what I post. And click on our course, intermediate algebra and geometry. And I click on this link. This the first announcement. Click on this. And let's log into that website. Access course. Continue. Okay, let's sign in there. Okay, open website. Right. I'm going to take a look at some of the questions, three questions from one of the exercise called trig word problems, right? So now this is cumulative practice final exam. We're going to do it tomorrow. Okay, so tomorrow we're going to work on this together, right? Today we're going to look at the trig word problems. And let's look at some of the questions here. There's a video here. So, for the horizontal line is called angle downward elevation. Yeah. Altitude. All right, then let's look at this question right here. Problem refer to the figure right here, right? Below, which is the illustration of the surveyor standing on top of the building. So this is surveyor here, standing on top of the building. Use the figure to sketch the labeled angle. The angle of the depression from the eye of the surveyor to the base of the opposite building. All right, this is the base of the opposite building, right? So this is suppressed depression. Okay. And then which one describe this? What do you think? This is the base of the opposite building, right? This is the base. Base is right here. So they do this. The surveyor is staring down to the base. They form this angle. This is terminal angle. And then this horizontal, right? So we form a horizontal angle of 35 degrees. So that would be so the angle of depression. So it is this angle is 35 degree, right? So I guess I'll draw this and I'll screenshot this so we can see this, how that goes. It's easier if you draw the graph. So this is the eye of the angle of depression. So the eye of this, the base, front eye of the surveyor to the base of the opposite building. Angle depression, so this is angle depression, 35 degrees. It's the base of building, right? 35 degrees. That being said, if you want to do the other, like, so this angle here will be the same thing as this angle here. So that's why you'll be so let's see which one will satisfy this. Either this one, if we see some graph like this, it's okay, right? Or the other one will be okay. And let's say if this is 35 degrees, then this one will be 55 degrees. Because this is 90 degrees. Same thing here, right? So for that, it's 90 degrees, and this one will be 55 degrees. Because these two are parallel. So the internal angle will have the same measurement. Internal angle that these two are parallel as well. And let's see which one captures this. We get this, right? This one is 55 degrees. So that'll be something like this, right? Let's see anything. This one best describes. Okay, so this is the correct answer. This one is the correct answer. Yep, it is correct. Okay. All right. Let's see. Angle elevation. Okay, this one is about angle elevation. So the problem refer to the figure below. Elevation is looking out, right? Top the building. So let me screenshot this and actually guys try this really quickly. Okay, let's look at this question here. So the angle of the elevation, right? It's elevated all the way to the top. The eye of the surveyor to the top, the opposite building. So this is angle elevation, and this is 50 degrees. So that's how you draw this graph. So 50-degree angle, and then let's go back. There will be this, right? Okay. So there. Yep, just so this let's go answer, right? Submitted, it's correct. Okay. Now let's take a look at this. So the height of the right circular cone is 25 centimeter, right? If the diameter of the base is 12.6 centimeters, what angle theta does the side of the cone make with the base? See the figure below. Okay, I'll let you try it really quickly. This is a pretty interesting question. This 12.6 is the entire diameter. Entire thing, entire diameter is 12.6. So we'll find out the angle theta, which is represents the side of the cone made with the base. This is the base, and you're looking for this angle right here, angle theta. Okay, let's go over the solution here. So we're looking for this angle theta right here. So we know the height, which is 25.5 centimeter, and we also know half of the diameter, which is the radius here. The radius is going to be 12.6 by 2, which is 6.3. So based on these two, we can create a tangent theta. Tangent theta equals to opposite over adjacent, so it's 25/5 over 6.3. And then we're looking for theta. Theta is going to be inverse of the tangent 25.5 over 6.3. And we get an angle. So you want to run the answer to one decimal place. Let's go back to the calculator. Yeah, okay. So you're gonna do arctangent, and then 25.5 over 6.3. And that gives us 76.1 degree. So the answer is 76.1. Then you put in 76.1. Any question about this? Show my work. Okay. So here, you can upload, right? You can take picture of this. Let's say, if I want to do it, I would take picture of the work I just did. Like here, and take picture, right? And then upload it. I can even save this. Let me see. Let me see. Okay, I can save this and I upload it. Right, like I saved it as a solution for two. Okay, I'm gonna save it. And right here, go back here. You can click on upload file, and under downloads, click on this. Open, and you can upload this. Submit answers. Once you upload the file, see it's right here. Submit the answer. So I can show all, and I'm looking to all the work you did. Right, this is the correct answer. Also the uploaded solution here. If you want to open it, then you can open it from there. Okay. So in the final, you should upload the solution, right? So to be on the safe side, so I can give you partial credit if you made a mistake on some problems. In terms of final answer, I will look into your work and give you some partial credit. We are skiing down the mountain with a vertical height of 1,200 feet. The distance from the top of the mountain to the base is 2,400 feet. What's the angle of that elevation from the base to the top of the mountain? Okay. You guys try this, right, really quickly.
All right, so you're gonna draw a graph. So you see, so this is top of mountain, right? This height is 1,200 feet on the ground. Okay, so this usually mountain, right? It's perpendicular to the ground. So this vertical height is 1,200 feet. And the distance from the top of the mountain, this is top of the mountain to the base will be 2,400 feet. And now you want to find out angle elevation from the base. This is the base. Base is here, all the way to the mountain, right? So you're looking for this angle here. And this is the angle theta we're looking for. So basically, we're using the sine theta to equal to opposite over hypotenuse, 1,200 over 2,400. This turned out to be half. And this is special angle, and sine theta equal to half, theta equal to 30 degrees. So elevation turned out to be 30 degrees. It is not a special value, and you use a calculator to get to figure out the angle here. So in this case, 30 degrees. Any question about this? And again, you can upload the work, upload the file here. That's correct answer. And let's see, question 7, we're gonna do one more, right? A biologist want to know the width of the river, right? This is the width of the river. And given that this is 100 feet from point C, right? This is 100 feet down below, theta equal to 60 degrees. So you want to find out how wide is the river.
So I just double checked your homework completion, right? Again, you have until 25th to finish all the homework. Okay, so make sure you catch up with all the homework, right? Okay, so let's go over solutions. So we're looking for W here. Theta is a 60 degree. We do a tangent theta, right? We do tangent theta, tangent 60 degree equal to opposite, which is W, over adjacent 100 feet. Tangent 60 is radical 3, right? Special angles, radical 3 equal to W over 100. Make proportion, W times 1 is W, 100 times radical 3. And this is the answer, and then radical 3 is 1.732 meter times 1.732. So it's a hundredth, and or if you want to use a calculator, no problem. You can always use a calculator. We don't have to memorize this. A radical 3 here. W is approximately equal to 100 times, run to one decimal place. 100 times radical 3. So 3, and then it's 173.2. Okay, so the answer is 173.2. Okay, and let's put it, I check the answer. All right, so tomorrow we're gonna review for the final exam, and on Thursday we take the final exam. And that's pretty much it for the Immersion 2. And I double checked, the answer is, I think it's good. Yes, it's perfect. Okay, so that's pretty much everything for today. So tomorrow, one more time, we're gonna work on the midterm exam review. And if you have any question, right, from the homework, if you have more time later, we're gonna work on this, try this final exam tomorrow. And this is a trial 56 final lockdown browser file uploads. And eventually they're gonna put this final exam. He hasn't uploaded yet, right? But he uploaded. See, uploaded. Show you. Okay. Yes. Before we end the session, do you have any question? So I guess I will